Biorefinery System Module 10 Lignocellulose Biorefinery Product Engineering Part 2 Segment 1 Biobased Materials. With me, Yusuf from Bioengineering Study Program, School of Life Sciences and Technology, Institut Teknologi Bandung. In this module, we will discuss about bio-based materials as well as food and animal feed. About 80% of chemical products are still based on crude oil. However, bio-based materials will increasingly gain importance. Bio-based plastics have a history of over 150 years. Key milestones include the invention of cellulose nitrates in the 1860s, man-made cellulose in 1890s, cellulose hydrate films in 1912, casein protein in the 1930s, and soy-based plastics in the 1930s. These materials lost their importance with the rise of the petrochemical industry in the 1950s. Since the 1980s, there has been increasing interest in the development of biodegradable plastics such as polylactic acid and various types of thermoplastic starch made from bio-based feedstock. The renaissance of bio-based plastics and bio-based materials in general has been fueled by progress in biotechnology, high fossil fuel prices, as well as environmental concerns. Bio-based materials have the potential to reduce non-renewable energy use as compared to conventional materials, but it may come at the cost of additional land use and related environmental impacts. Cellulose acetate is one of the most commercially important cellulose derivatives and is widely used as fiber, film, paint, filters, and dialyzers. A major application is in cigarette filters to remove particulates during smoking. As fiber, cellulose acetate is used in textiles because of its relatively low cost, draping quality, softness, comfort, luster, and natural feel. The material is also used as a substrate for the motion picture camera film. It also finds application as an ingredient in sheet and molded objects and as an additive in surface coatings and inks. It is estimated that 1.5 billion pounds of cellulose acetate are manufactured globally every year. A recent study has proposed the use of waste straw as the crude material, with the straw undergoing acetylation reaction after the pre-treatment by steam explosion, and then cellulose acetate was separated from the acetylation products of straw according to their different properties as shown in the right figure. This technology used to produce cellulose acetate from acetylation reactions of straw has the advantages of low cost and simplicity, which is conducive to establish an ecological industry model in which cellulose acetate is regarded as a flagship product. Sodium carboxymethyl cellulose is one of the most important products of cellulose ethers, which are formed by natural cellulose modification as a kind of cellulose derivative with an ether structure. CMC could be used as a flow-collating agent, gelating agent, emulsifier, thickening agent, water-retaining agent, sizing agent, and film-forming material, and so on. CMC also widely applied in fields such as electronic, pesticides, leather, plastics, printing, ceramics, and the daily use chemical industry. The cellulose materials for CMC production are still concentrated in the linder and wood pulp, which have a relatively high cellulose content and degree of polymerization. Such materials are not abundant and have a high cost. In addition, the pre-treatment processes are also complex and will damage the environment. Therefore, it is very important to search for cheaper raw materials to simplify pre-treatment technologies and to decrease the pre-treatment cost. Previous research has indicated that straw, sugarcane, bamboo, paper sludge, and many others could be the raw materials of industrial CMC preparation. The different components of straw are separated according to the different physical and chemical properties of the products, and the high-value CMC is then produced following the rules as shown in the figure. In such process, the raw materials are cheap and the technology route is relatively simple, which is of great importance in the respect of realizing the component separation of straw, saving resources and making the production technology become environmental friendly. Desertification is an important ecological problem in the world. Drought, vegetation deterioration, and poor soil texture are the main driving force of soil desertification. Therefore, researchers around the world have realized that the fundamental actions needed to prevent soil desertification are to improve the soil texture, improve the water conservation force, and strengthen the vegetation construction. Plenty of studies have been carried out around these measures and chemical materials. However, the cost of chemical material is high, and the absorptivity of plants for massive chemical amendments is limited. Moreover, a lengthy period of chemical amendments usage would pollute the underground water, make the soil hardened, and destroy the environment. Under such conditions, there is an urgent need to find a biodegradable material that could solve the problems effectively and enhance soil fertility. Conventionally, most of the domestic practice of treating straw to be used as desert soil amendment material is simple mechanical pulverization. Straws after such simple pre-treatment are of poor quality. The stacking and ratting period is so long, and the fertilizer efficiency is low when returning to the field. Recent technology route for production of desert soil amendment material is shown in the right figure. By applying steam explosion, the water absorption and water retention rates are increased by 32 to 40% and 80 to 100% respectively as compared to pulverizing straw via machines. Moreover, after solid-state fermentation, the materials function as a biofertilizer and prophylaxis treatment for plant disease. The organic content of desert soil amendment materials after solid-state fermentation exceeds 60% of humic acid contained is less 15%. The total number of active bacteria is 300 million per gram, and the N, P, and K contents are all higher than 5%. Therefore, such bio-based desert soil amendment materials are propitious to the large-scale application of desert land control. Recently, the market for building materials has turned to quality from an initial emphasis on quantity, and one of the most active fields in the building materials market has become the production of boards for construction and structural shapes from lignocellulose. Due to the low cost of both straw raw material and materials used in its processing, the cost of lignocellulose board is lower than any other boards of the same time. The preparation of straw boards has successfully relieved the situation of undersupply of domestic wood raw materials, which also opens up a new route of straw substitution for wood materials. Moreover, the success of straw boards could increase farmers' incomes and broaden income sources through developing the artificial straw boards. Besides, straw boards also solve the straw collection problem to some extent, remit the atmospheric pollution due to straw combustion, and at the same time decrease the consumption of a forest resource, thus protecting the environment. The structure and properties of straws are changed by physical, chemical, and biological methods. The application of modified straws currently focuses on all materials in the building industry. Straw building material is a kind of green building material that has a low weight. However, a certain amount of thermosetting resin and formaldehyde should be added during the production of all materials. Recently, a new concept has been proposed as shown in the right figure to modify straw and develop a set of methods for straw modification, via steam explosion based on straw modification methods and thermocuring. The abundant straw resources can be turned from waste into wealth via straw modification technology. It is expected that the market capacity for building boards is considerable and represents a promising source for future economic growth. For the next segment, we will discuss about food and animal feed. Until then, I am Yusuf from Teknologi Bandung.